Always forget to remove that. Hello, everybody. It is time. I have to say, I'm disappointed. I was gonna be so smart. I was gonna be so clever. Um, this is strudel. This is a kind of shitty, I have to say. Um, language for making music. Kind of shitty because it's JavaScript, so it makes no sense. You have to memorize the exact syntax, otherwise it will fail and you won't exactly know why. But I tried integrating it into OBS because OBS takes browsers and this thing runs in the browser, so I figured should be easy. Kind of. It's not super difficult, but controlling audio and making it autoplay from OBS is a pain in the ass. You have to literally press the play button. So yeah, most likely only worked one time. I guess we'll see. All right. It's day 4 technically of implementing multithreading, but day 2 of implementing the thing that I'm currently implementing should be going better than usual. I believe, I hope, I wish. Anything else you might say about that? All right. However, before I begin, I want to use Emacs, but Emacs is so shitty. I found out something way shittier about it recently, which is the fact that it doesn't let you indent however you want. That is so stupid. If I want to indent code like this, and I just cannot indent for the life of me, the physical key is doing nothing. This editor is so stupid. God. I'm sure if I read the manual and if I write enough Lisp, I can configure it to do what it's supposed to do, but like, is that really necessary? So there really isn't a good code editor out there. There really isn't one that just, like, the functionality of Emacs is good, but the usability of it is absolute shit. It doesn't really work, I would say. It just kind of exists. I literally am not allowed to indent here, like, whatsoever. Sometimes it works, but most of the times it literally does not. I have to be inside a code edit, inside an actual code file, and it has to allow me to indent according to its rules, not mine. And yesterday I spent a stupid amount of time configuring it to work with tabs. Well, not even with tabs, just like with the same amount of indentation that I want. And even that didn't work. Like, I had to set this thing, which didn't do anything. I had to set the tab width, and I had to tell it to indent with tabs. And even then, it doesn't actually indent. So as much as I would love to use Emacs, God, it's so annoying to use. It's just, it doesn't work. It doesn't work. It doesn't work. I'm sorry, but if it requires a ton of configuration to work, then it doesn't work. And it works for the gatekeepers, literally nobody else. Like, there's a learning curve for writing text. At some point, you have to realize you've gone wrong somewhere along the way. You've done it wrong. There is a learning curve for writing text. You did it wrong. There's not much to it. I'm sorry. I didn't read the manual. I didn't read the manual. Need to be born in the 80s or 70s? Alright. Scale issue then. God damn it. I was born in the wrong generation. Now, okay, so Emacs, genuinely go fuck yourself. Why is there a learning curve for a code editor? I swear to God. This is why people get so fixated on the tooling. Yesterday we were talking about how people get so fixated on which editor to use, which config to use, which Debian or Ubuntu or Arch or which Linux distro to use, which desktop environment and which window manager to use. This is the reason why, because they all have a genuine learning curve that they do not need. That is why we get so hung up on them. Because if they didn't have this learning curve, I'd just be using them to do things instead of wasting time with them. So anyway, someone mentioned Lem, which is supposed to be a modernized no, not a version of Emacs, because it's not Emacs at all. It's a modernized editor inspired by Emacs, essentially. I guess we'll see. I did install it. And someone also mentioned Doom Emacs, which is a thing. What did I say? An Emacs framework for the stubborn Martian hacker. The fuck are you talking about? A stubborn, shell-dwelling, and melodramatic vimmer. No, this is not for me. Also, Space Emacs is a thing, but I was told not so much, no. Speaking of threading, this is a nice idea. Let me see. Multi-core by default. Learning to program a single CPU core is difficult. There is an enormous number of techniques, amount of information, and number of hours to spend in order to learn to do it effectively. Learning to program multiple CPU cores to do work in parallel, all while these cores cooperate and accomplish some overarching task, seems like the anvil that broke the camel's back, so to speak. I forgot to get coffee. Holy shit. Alright, no, I'm refusing to continue until I get coffee. I'll be right back. I'm back. It's cold brew, so I didn't have to actually make the coffee. It was already made. Although I have to say, this coffee is not good for cold brew, so it really just looks like tea. It's not tea, though. Trust. It's coffee. Alright. Now that I've done that and spilled it all over my desk. Well, all over. Very nice. I already cleaned it. Alright. Now that I've gotten coffee and spilled a little bit on my desk and cleaned it up, it's time to continue reading this. Okay, so essentially, learning to program one CPU core is difficult. Learning to program multiple ones is even more difficult. There's already so much to wrangle when doing single core that for me it was much more convenient to ignore multi-core programming for a long time. I agree. But in the modern, or I don't agree. I felt the same way. Also, hi, Marcy. But in the modern computer hardware era, there emerges an elephant in the room. With modern CPU cores count far exceeding 1 and instead reaching numbers like 8, 16, 32, or 64. Linus Torvalds has like 128, I believe, something like that. He has like a crazy CPU, like $5,000 CPU, I believe. We leave an enormous amount of performance on the table by ignoring multi-core. Okay. I understand where you're going with this. I'm scared of where you might be going with this, though. But I feel like overall you might have a good idea, but I'm just genuinely terrified because I'm terrified of multi-threading. By the way, the title of today's stream is multi-threading in C, so... Also, hi, Elmigrant. I didn't actually say hi to you. I'm not a performance programmer. Like Casey Muratori, I've always wanted reasonable performance, but historically I've worked in domains where I control the data involved, like my own games and engines, where I'm either doing the art, design, level myself, or heavily involved in the process. Thus, I've been able to use my own programming constraint to inform artistic constraints. Yes. What's SEE? Or C? See if it crashes? All of that went out the window over the past few years when in my work on debuggers, I've needed to work with data which is not only under my control, but almost exactly identical to the opposite of what I'd want. All right. Can we get to the point though? There's a lot of further ado. This is because I've written about debuggers as are at a busy intersection. They deal with the unknown. Brother! Is the article about debugging? Because why are you talking about debugging? And if one wanted the debugger to be useful for extraordinarily large code bases that highly successful companies use to ship real things, those unknowns include unfortunate details about those code bases too. Scroll past the intro. So, debugging has nothing to do with it. How's Emacs so far? We're gonna talk about code editors after this article. But, well, I started the stream with a little bit of rant about that. Yeah, he loves it dearly and has had 0 issues. Me when I lie. I got actual cold brew coffee, but this is not that, so yeah, it's very... I'm drinking slightly bitter water. Also, I was running out of coffee, so this is like especially weaker. But now I have better coffee and I have cold brew coffee, so tomorrow's coffee is gonna be really good. Today's coffee though, got a little bit of the Earl Grey coffee going on. Because every programmer learns single-core programming first, it's common after one learns multi-core to apply those techniques conservatively within otherwise single-core code. Again, I like where you're going with this. Slightly bitter water is a great name for the coffee shop. Well, if you ever find a place called that in Madrid, you know who owns it. All right. Consider the following example. We're adding numbers. We compute a sum of all elements in the values array. Let's now consider a few properties of sums. Like, this is what, associative and commutative and isocommunicative. Whatever. Yeah, you can do these operations. Does it really matter? Because we can reconsider a sum of elements as a sum. Well, it doesn't matter for how to parallelize it, right? But the point is, you're parallelizing it. And then you're adding those sums together. And obviously, okay, so the original code is, yeah, just adding numbers together from an array. And here, you're doing it by dividing that array into 4, and then adding those together, and then adding the results together. Doesn't win us anything, but what it means is that we can obtain the same result by subdividing the computation into several smaller independent computations. Because several independent computations do not require rewriting the same memory, they fit nicely into multi-core programming. So we can do it with multi-core programming. This person goes on and on and on. It's a bit... it looks like a really long article, by the way. Yeah, not reading this whole thing, but like you don't have to make it a long article. You just chose to make it a long article. Very American style presentation. Okay, so what you're gonna want to do is you're gonna want to go ahead and get started with parallelizing your code at every step of the way, is what I believe the article is trying to say. The basic idea is you do the same as shaders. All right. For cases like this, wait, can I maybe just skip through until I find a snippet and read the text before the snippet? I feel like that's a good way to summarize this article. We can implement what's known as a parallel for. The idea is that we'd like to specify our original for loop, but also express that the loop can be subdivided. Okay. And there's some very ugly code for doing that. Which does put it in its own little task. And then they're doing, I forgot the trigger warning for this stream. Today we will be using a word. It's this one. This word over here. The 3-letter word that some people might find offensive. Please take care of yourself if that's you. So long so you can paywall further articles. What's the paywall? This is an entire encyclopedia. You need to multi-thread the article. That's it. That's it. Okay, so you spawn n threads, then they all have the same entry point and can wait on each other with stuff like if thread ID is 0 and wait for other threads to get here. And not just parallel programming. Don't you already do that? One desirable property of the parallels for is that all jobs which execute at roughly the same time across some number of cores are identical in their shape. Furthermore, between a parallel for's job, each lifetime is scoped by the original single-core code's lifetime. Mechanism often used to implement parallel fors is rarely only used in this way, which is understandable given its highly generic structure. Ooh, this is long. The critical insight I learned from speaking with Casey. Can I just talk to Casey directly and ask him what the point of this article is? I feel like that might be more straightforward. I'm just gonna email Casey Moratori real quick and get the article. Yeah, get the summary from him. A significant reason why these costs arise is because of the careful organization a system needs in order to switch from single core to multi-core. Mechanisms like the job system and their special use case in parallel force represent in some sense the most conservative application of multi-core code. GPU shaders. The point has been reached. Look how deep into the article we are. Is that the scroll bar? That is the scroll bar. Look how deep into the article we are. The point has been reached, which I know because of the chat, not because of the article. GPU programming model to the usual CPU programming model, you author a single function which is scheduled onto a single core only, normally by a kernel scheduler. Using a single thread state, this model is in contrast, single core by default. Multi-core by default. Now we've reached... now you're thinking with threads. Let's begin by exactly inverting the approach. Instead of having a single thread which kicks off many worker threads, let's have many threads all running the same code by default. In a sense, let's just have one big parallel for. So you create, yeah, threads by default, okay. To click into an architecture which assumes a single-threaded entry point, we start with a bootstrap entry point, but the only work this function actually does is launch all the threads executing the actual entry point. Let's consider what's the point of that. There's a lot of code that you only need to run once. Is the main reason why we don't do multi-threaded everything. There's only so many things that you need multiples of. But of course, when all you're doing is a for loop adding values together, I get it. We obtain these somehow. Just skipping over the complex parts of multi-threading like that. Right, but essentially you do multi-threaded by default. Okay, but what if my code is not a for loop? It's like running multiple AI agents at once. Ah. And now I'm no longer using agents. Now I'm looping. I'm no longer looping. I'm writing conditional agents now. I'm not writing conditional agents anymore. That's so 2027. I'm in 2028. I am actually just prompting the LLM directly. By the way, I had to ask an LLM how to do something. I was like, well, let me use the agent so I can token max a little bit. And it took like 5 minutes. I really just needed it to fix a couple lines where the syntax was not correct. For the synchronous code, actually. It took so long. It would have been so much faster if I took my function, copied it, pasted it, and was like, what's wrong with this function? And it told me, and then I just pasted the result or wrote it myself. Great job with the agents, guys. Oh, my productivity is going up 10x during vacation and during my free time. Productivity when I'm actually supposed to use LLMs is going way down. Whoops. Deciding per thread work, combining all thread sums. Okay, so barriers and the usual for multi-threading code. Look. Yeah. I'm gonna be honest. The biggest issue that I have with multi-threading code is that it's not that straightforward to write. Like, for example, a lot of languages now do await and async, where async means this function is going to be asynchronous, and await means wait for the asynchronous function to fully finish. So that's really cool, right? So I can have an asynchronous function, and then await func means wait until this code has finished, then resume execution of what we're currently doing. That makes multi-threading so easy. And yet, so many languages love to add all of these little limitations to it. Make sure that you do it. Oh, you're not allowed to use this from here. Oh, you're not supposed to do that there. Swift in particular, I find so annoying when it comes to that. It's like, oh, you want to use async? Cool. By the way, everything you do is going to be asynchronous. All of it. Literally all of it. Oh, you want to go back to the main thread? Yeah, you can do that, I guess. Sure, but don't you want to stay in an asynchronous environment? Oh, by the way, you're not allowed to access this from here. Oh, you're trying to schedule code on the main thread for asynchron? No, buddy. No. Sorry. Not gonna let you do that one. Oh my god. Like, async and await fix the problem of writing most asynchronous and most thread-based code. And yet, they make it so annoying by the amount of limitations that they add. I'm especially talking about Swift, but not exclusively. Another thing that I noticed is in Swift, doing something like getting the current view, which it used to be, you used to do like UI window dot current dot key view controller. Don't quote me on this, but something like that. You just needed to access the current Windows current view controller. On iOS, there is only going to be one window. So super straightforward code. This is no longer the way to do it. Now you need to get the UI, scene, current scene. You need to cast it to a window scene, which is going to make it optional, of course. So you're going to have to check that it's, you know, a valid value. If not, you're going to need to, you know, then access windows. You don't get to access current window anymore. You have to access windows first, which can also be optional, of course. Then you can get the view controller. Oh, and by the way, this entire thing is asynchronous. So, await. Oh, but you're trying to run await from a normal function. No, no, no. Your function needs to also be asynchronous because it's awaiting. This is something that actually happens in iOS nowadays. I don't know. I think they're losing the plot when it comes to asynchronous code. They're very much losing the plot when it comes to that. Kind of crazy. I'm not sure what Apple's is up to nowadays, but it's not great. Next month, half of them will be deprecated. Exactly. Okay. Not gonna lie, I would like to make asynchronous code very simple to do in my OS. But yeah, parallelizing by default doesn't mean much if I still have to write all the boilerplate for parallel. Is that? Do they ever get to the point in this article of let's make it easy to write asynchronous code? Doesn't look like it. Doesn't look like it. There's a lot of boilerplate to do in asynchronous code, and I'm seeing the same boilerplate here. That is my biggest issue. If I wanted to parallelize a for operation, and I have to write like a million lines of boilerplate for it, and then I have to consider a million different like synchronization things. You know what's faster? A for loop. Just a for loop. That's it. It's that easy. It's that easy. My God. The problem with Swift is that they both want to abstract stuff like pointers and threading and also be correct and save 100% of the cases, which leads to 12 pointer types and crazy rules like it is. Yeah, exactly. It's not as bad as Rust when it comes to being safe 100% of the cases, but it's getting to a point where it's ridiculous. I also would not recommend Swift for low-level programming because like they literally have it on their website too. This is not the Apple website, it's the Swift website, right? But it has an entire section for embedded, but then you look at any code in here and it's awful. While true, LED toggle sleep. Wow, how elegant. Oh my God, that is so elegant. Cool, right? And I do have to say, the syntax of Swift, I like it. Swift UI, sent from above. However, oh, they removed that one thing. I think, unless I needed to click on something else to find it. But it has the same problem as Rust, which is like, in order to access the field that you're going to access to do this toggle, you're going to do it in an unsafe manner. So you're going to have to explicitly tell it, hey, this part is going to be unsafe. And that's really annoying for writing embedded code. If you have to constantly ask the programming language for permission to do things directly with memory, it's not a good language for low level, and it's not a good language for embedded. Don't put it on your website. Also, very common. I made an operating system in Rust. "10 out of 10 times, it's gonna look like this." I made an OS in Rust. It's memory safe. First thing you see, unsafe. Boom. Chef's kiss. Absolutely beautiful. Hello, Camilson. I am Venezuelan Italian and I live in Spain. All right. Have you seen Phil C? Maybe the Woocash Casey Phil podcast on that? No. Ventalian, who lives in Spain, yeah. Nobody's gonna understand that, but sure. Yeah, that works. I've heard of Phil C a while ago. A lot of people were talking about it. I haven't heard about it in months. And I remember that it actually compiles to C. So I remember hearing about it at the same time that I was starting my message. What? My programming language that compiles to C. Runtime checks to prevent exploitable memory safety errors. Runtime checks. That means overhead. There's one good thing about Rust and Swift. They do compile time, memory, and type safety. So it happens while you're compiling. This is going to make the program slower. Whereas instead, when I do it with a compiled language that is safe, while I'm compiling, it does all the safety checks, and then I produce an executable that is considered to be safe according to, what the language is able to do. For that matter, can't you just bring into a static compiler, a static analyzer into C? Hello, Hisoka. It's going well. How are you? I don't get this memory safety being the most important thing for a language to fix. Like, come on, use arenas and they'll be like they fix like 96% of memory bugs in your apps. Kind of. Kind of. But not really. But it's just like, more so, I don't see the issue as being like memory safety. It's the fact that a lot of people who do these memory safe languages then treat it like, okay, my program can do no wrong. Your program can and does do wrong, as a matter of fact. Jester's dreaming. It's just off camera. You can see his head, actually. Very, very small. You have to either have static analysis proof and your code is limited to what can be analyzed, or you do runtime and it's a bit slower. Yeah, that's true. To be fair, you can enable a runtime sanitizer. And you can do all of these things. You can do static analyzing. Yeah. We do. Well, I don't do that. But people do go crazy for the memory safety. And again, throwing these languages in places where they don't belong. Like, I can't tell you how many times I've seen this in somebody's Rust operating system. This is a hint that you should not be using Rust. This is not the actual syntax. I'm sure there's a whole lot of other bullshit because Rust is like really, really bad syntax, by the way. But like, this is the point of it, of what I'm saying. Okay. Before I begin writing code, Emacs, love of God. Last night I tried getting it to indent my code, and it's literally impossible. I'm sure if I write 50 more lines of Lisp, I can figure it out. I don't want to do that. So, I installed Lem, but I don't know how to use it. But maybe we're gonna give Lem a try. And Lem, what do they describe themselves as? A general purpose editor and IDE extensible in Common Lisp. It seems very Emacs-like. And I like the philosophy of Emacs. I guess we'll see if I like this. Yeah, also, if you rely on tools that are not memory safe, there's not much happening with Rust. What happens when you dynamically load the C library in Rust and it's not like what you expect memory layout-wise? Probably, yeah, you can't statically analyze. I don't know how it works, honestly. Okay, I mean, I don't want to write Lisp. This is a normal IDE, right? Because you're focusing way too much on the Lisp parts of it, and it scares me. Probably just, well, not crash. It probably won't compile. I don't know. I'll never download a Rust. Well, actually, I did download a Rust compiler because of Tree Sitter. Unfortunate. I did. And, yeah. Okay. So this is lem. One thing I don't like about it. We're in the terminal. Okay. Recent projects is R. Or not, because I just pressed it and it does nothing. Do I have to do Control R? No. I have Control R, Alt R? No. Nope, not Alt R. Okay, so we're off to an amazing start where it says something here. Although it does say nil, and I don't have any projects open, so new Lisp scratch buffer. Open the lem init file. So let's do that. Okay, that works. It's empty. Cool. How do I close it? Is it Control Q? Of course it's not. Control C? Of course it's not. God forbid we use the standards. Usage. Quick start. Alright. Control X, Control F. Control X, Control S. To save many buffers as one, Control XS. To switch windows, Control XO. Alt O. To make a window full screen, Control X1. Okay. Let's do Control X, Control F. And we're going to try to open. Wait, what about opening a project? Oh, can I open a project from here? That would make sense, right? If I just do this. Okay, I can do that. Hello, Kayal. So far, it's like 10 times more intuitive than Emacs. That's, 10 times 0.00001. So it's not a huge number, but it's something. Control X, O, no. Control X, Control O, no, also no. You said Control X, no, hold on, to open a new window. I want to open a new window. Split vertically. Okay, CX3, right? CX3. Alright, then I can make this one like... No, I can't. No, I can't. Emacs actually allows me to do that. Why do you not allow me to do that? Come on. Split screen. Come on. Lord. So I'm not really seeing much of a point to it. If it's gonna be the same key bindings as Emacs, and worse. Again, let me find some time to do my own editor. In the meantime, we're gonna stick to Z. Alright. Better than GNOME? What is... Okay, the ePlasma, yes. Meh. By the way, OBS fixed itself. Remember how yesterday all the buttons were super, super tiny? They're fine now. That actually looks slightly big on this screen, but it looks fine on this one, so I'm good. Linux jank. Linux jank. Alright. So, yesterday, let's just ignore this whole code editor bullshit, because I'm genuinely so... Just gonna do my own thing. Yesterday we made a system for synchronizing threads called a job system, where essentially I'm using the file system for it. All of it is going to be based on the file system. All inter-process communication is going to happen through the file system. So, for example, the terminal is mounting a new file system called term history. It's doing that. And we wrote a function for it that is... Why didn't that work? Okay, I see. I was pressing the wrong key. Term history, there it is. You can see it's grayed out because this file browser tries to access... well, first off, it gets a list of all directories, and then it tries to do stat for all of those directories. Stat is going to tell it whether it's a directory or a file, which is going to color it differently. If stat fails, it grays it out and does not allow you to enter it or do anything with that file. So it's grayed out right now, which means it failed, but technically didn't. If we look here, it says hello, which is coming from the terminals. By the way, I can delete the terminals like C++ code now. It is coming from the terminals stat function. So stat is being called, but two things that are happening. These are 0, and this is not being sent anywhere back as a result. So I did a whole thread synchronization thing where essentially when this process asks for /term history, gets stat on term history, the kernel sees that and is like, wait, term history is not owned by me. It is owned by... Where the fuck are you going? It is owned by the terminal. So I'm going to block your execution. I'm going to ask the terminal to run stat in a new thread. When that thread and I'm going to create a job ID for this whole thing to synchronize between the two. When the thread finishes, it is going to report that the job is fulfilled, and I will be able to unblock your execution. That is happening, but there's no data transfer between the two. That's what we need to do today. All right. Should have listened to you yesterday, but are you writing with ARM, Asm? No, yeah, it's ARM. It's only ARM. Hello, Peter. A graphical editor is always better. Yes. Listen, I like that Emacs is technically a graphical editor, even though it doesn't understand graphics. It works like a graphical editor. It doesn't run in the terminal. It allows me to use the mouse just fine, which is something that NeoVim, for example, doesn't do very well. I just don't like its default and how difficult it is to configure, because you genuinely have to tinker with, like, again, I had to tinker with like a million settings yesterday to get it to indent with the same indentation as my normal code. Although I did see one thing in Emacs that I really liked. What are you bouncing around for? What are you doing? Okay, there we go. I did see one thing in Emacs, and that is for C, style, guess style from this buffer. So you already have a code base with its own style, guess the style from it. That is pretty cool. What I don't like about Emacs, for example, is autocomplete just worked for the first time. I don't know how to get autocomplete to work, how to get autocomplete to play nicely with indentations, how to indent my code properly. Why are you autocomplete? What is that autocomplete? It added page twice. How is that autocomplete? That is stupid. Anyway, I also found out how to do like LSP by default, and yesterday it wasn't doing autocomplete. Today it's doing it a little bit too much. So what the fuck are you up to, Emacs? Anyway, I would like to use Emacs, but I need a modernized version of Emacs. The shit where we're catering to programmers, to how programmers were using this shit in the 1970s makes no sense. That's enough of that. At some point, you need to make some breaking changes to your software, I believe. If somebody doesn't like it, doesn't matter. You know what? It's an open source project. Fork it. If you don't do it that way, you can go fork yourself, honestly. Although it does, on the other hand, mean that technically if I wanted to, I should fork Emacs and make it work like I want, but I would rather do my own thing. I guess it is the good thing of doing this. You should try Helix. I've tried Helix a while ago. It was okay. I feel like NeoVim did the same things that it does. But I don't know. Again, I think the solution here is to continue working on my code, my code editor. Which again, really, I just wanted to, the thing that I love about Emacs is that it's text-based. This is a text-based program. Let's ignore the IDE part. Let's ignore the code editor thing. Does it even describe itself as a code editor? If I go to like GNU Emacs, it describes itself as a text editor. And that is what it is. It allows you to customize text, and it's great for that. It's pretty amazing for that. It's just antiquated. But it treats everything as text, and that is really cool. Although there are icons here, for example, which is like, okay, that's technically not text. But like, and this is Tremax, to be fair, which is a plugin. Maybe they're doing things a little differently. But yeah, literally everything in it is text, and that can allow you to do some interesting things. Which is why I say Emacs is what a terminal should have been. Because in the terminal, everything is text. But it really misses its potential. It doesn't know that a mouse exists because they're emulating devices from the 70s. Which Emacs is also doing, but at least they know what a mouse is. That's something. They've modernized themselves a little bit more for some reason. Yeah. I like the text-based functionality of it. A power user of Emacs can tell you just how powerful, the fact that everything is text-based can be so powerful. There's a lot of interoperability between things, but it doesn't change the fact that, the interface for how to use it is my problem with it. And I don't think that Vim has that same philosophy. And Helix doesn't have that same philosophy, which is why I don't even care to try them. Lazy Vim. I tried Lazy Vim. Feels the same way. Genuinely. Nah. Also, the same thing goes for like the same issue that I have with Emacs. All these keystrokes that are absolutely ridiculous because they come from a time before we had any kind of standard. But now we have standards, so adapt. They're useful, they're well known, they're intuitive as hell. Use them. Literally every other program. There's such a gap between software used by developers and software not used by developers. It's crazy. That's my biggest issue with it. So I want to make something like this, but user-friendly. Wait, I didn't invest the time into it when I first started programming, and at this point I've been using VS Code for so long that I'd rather use a tool I know that learned Emacs. See, the thing is that even if you had... would anyone use Emacs as a beginner? No. Unless that's the only thing that you had back in the day. I don't know. Anyway, we do get too hung up on tooling, but the reason we get so hung up on tooling, like I said at the beginning, is because there is so much of a learning curve. You're gonna be fine with VS Code, you're gonna be fine with Z. I just wish they had some of the capabilities that Emacs has, and I wish they were in vibe coding. But hey. Alright. A bunch of my buddies use Vim as their first IDE. That is crazy. Okay, So, well, maybe I want to wait a little bit because there is another thing that Emacs does. Brother, fuck right off. Close without saving. That buffer is still there. Brother. I do have Blender open. I hope that didn't not save my work. I was doing something. Anyway, my indentation. My indentation. You see how easy it is to indent stuff here? This is how Emacs should work. If you're a text editor, act like it. Edit text in a smart way, but don't act like you know better than me. If I want to indent it more for whatever reason, I can. And I can just go back. Thinking of it as a text editor is the problem. It is simply a Lisp with some additional texts and buffer functions. Can't be compared to normal editors in my opinion. You may understand why I'm doing that. I think you get why I'm doing that. I get the point. I get that. That's the part that I like about it. What I don't like is the lack of ease of use. The lack of usability, actually. It's like complete what acronym did we come up with yesterday? GNU is not usable. I said something really stupid and then chat came up with something better. So GNU stands for GNU is not usable. On top of everything, it also has the proprietary GNU jank, which is almost endearing, or it would be if it wasn't so fucking annoying. Can't tell you how many times I've had like a memory bug or something that a debugger would be perfect for. I run GDB, completely ignores my shit, crashes the program just by launching GDB. Sometimes set a breakpoint, ignores the breakpoint, but if there's a print, the print shows, meaning we actually hit the breakpoint. GDB just didn't realize. It's just like, oh shit, I fell asleep. Oh fuck, you hit the break. Oh, next time, buddy. Next time. That's great, but I ignored all the AI, built-in AI features because it still feels so rough. Like these agent systems are still so new and haven't really established a good foothold yet. They seem to have established a good foothold into the code base, though. It's starting to feel really, really glitchy. That's my biggest issue with it. Although I do have to say, after using Emacs for a little bit these days, I'm seeing the potential, which is why I keep trying to go back to it. But whenever I try to go back to it, it pisses me the fuck off. That's my problem with Emacs. I'm like, oh my god, I want to use you. Why are you so shit? Why are you so janky? Why are you so difficult? Why are you like this? I just wanna use this program. Actually learning how to use GDB is a genuinely good skill. It's another skill issue on their end. If I do GDB and I set a breakpoint at a specific point and you tell me that you set a breakpoint and then I hit that specific point and you don't hit the breakpoint, how is that my fault? How is that a skill issue for me? That feels like it doesn't require any kind of skill. It shouldn't require any kind of skill. If it requires skill to hit a breakpoint correctly when the program makes you think that you're gonna be hitting the breakpoint correctly, that's a shortcoming of the program, not of the programmer. Well, not of the user, I mean. Ease of use is just trading power and extensibility. What if you want per buffer, per language indentation levels? Can you easily do that in a single function of code in Z? Not in Z. You can do it in a JSON file. That's not great. But honestly, structure-wise, if it was using Lisp instead of JSON, yeah, sure, you could. Does Z actually have scratch buffers, by the way? So that's one thing that I really liked. I can always open an empty buffer and not save it, but is there a persistent scratch buffer that I can easily open? Because I was able to do this keystroke that does nothing on Z. You know, I never knew that discussions is a thing on GitHub. Doom Emacs binds scratch buffer to this. Okay. I added an MD file as a buffer. Hope it helps. That's not a scratch buffer though. All right. Again, after this multi-threading thing, we're gonna move on to Lisp, terminal scripting with Lisp, and code editor, also scriptable with Lisp, because that's another thing that I really like about both Lisp and Emacs. So we'll do that. And then you will see Emacs. Then you will see how it's done. Totally. I never like debuggers in any IDE. Like print statements tell me all I need. Nah, same. And print statements are not gonna fail me like that. But sometimes it can be useful, like, okay, this memory corruption, let's say, right? There's a value, it's being overwritten by someone that shouldn't be overwriting it. I set a watch there. Never gets triggered. The value still gets overwritten. My program crashes. I never found out anything from GDB. It is a genuinely useless debugger. And because I'm working with cross-compilation for the operating system, I'm not really allowed to use other debuggers. Also, some good debuggers are only for Windows right now, so that also doesn't help. Anyway, there is an ad break, so I'm going to get some more coffee. I'll be back in 2 minutes. Actually, screw it, I'm back now. Good thing about cold brew Earl Grey over here. Earl Grey coffee. Debugging in other languages seems very confused to me. I use breaks, but I feel like I would die without a Lisp debugger. I've never used a Lisp debugger yet. I should, so I know how they work. If I'm planning on making so much software Lisp-based that, yeah, I should probably learn that. You know, I do have to say, Lisp is a genuinely great language for doing preferences for your programs, and you could easily wrap it in a UI if you wanted to. That's pretty good of Lisp. Like the Emacs file is a great way to do. It can get pretty disorganized, honestly. That part is not great, but I'm sure there's better ways to organize it. I'm just putting everything here. I'm sure you could just load other packages and just like subdivide things. Or again, I don't know what convention Emacs users normally go for, but yeah. Debugging in Lisp, evaluation pauses, you can fix the issue, resume it right there. It's magical for game dev. Yeah, it does have like a lot of things in Lisp. It's crazy how a C programmer or even like higher level languages, you know, your Rusts, Zigs, Swifts, um, Odins, all of these languages have all these features and they have all of this infrastructure to power these features. And then Lisp comes along with a syntax so simple. And it's just like, yeah, I have those too. I've had them since 1958. Just mugs all of these languages. It's incredible. And then when you understand how they work, it's so simple that it's like, holy shit. We've really been overcomplicating things. Like, okay, look at this. This here is the IR for my compiler for the C style code. You got blocks, declarations, asses, assignments, arguments, not exponents, what are these called? Expressions, calling functions, conditions. This is the same code for Lisp. That is all you need. That is the same code for all of those things in Lisp. It's all the same thing. And it has so many things that C doesn't have. You have forward declaration. Well, you don't need forward declarations. You don't need a double pass compiler either. You have lambdas. You don't need any kind of like code rearranging. Genuinely insane how simple it is of a language and how it has features that I consider to be modern. That as in programming languages didn't have them 10, 15 years ago, or they weren't super common. And Lisp had them from 1958. All right. Let me begin writing some stuff. Again, we're going to do a code editor very soon, so all of this stuff is going to be considered then. However, what is this? What is this change? Fuck's sake, Lisp. Emacs. Okay, so I mentioned we have thread synchronization, right? One process can ask another process to give it a resource. We are given a job ID. The first process is blocked until the second process has a thread scheduled, a worker thread scheduled. When the worker thread finishes, the first one gets unblocked, but there's no data synchronization between them. All of this happens in the file system. All of this is file system based because everything is a file. So, well, in my system, it's more like almost everything is a file. Then again, so in Unix. Not so much in Plan 9. In Plan 9, everything is absolutely a file. In my system, there's a little bit of, I haven't made that a file yet. I haven't really needed it. So, yeah, it's probably a file. Everything's probably a file. That is the philosophy. Everything is probably a file. Actually, everything is probably a file. That is the philosophy of my system. Yeah, so we created the jobs, and you submit a job application. Well, you don't. The kernel does. But the kernel submits a job application to say, hey, need a resource from this process. This guy's requesting. Block this guy. Schedule this guy. This is the resource that we're going to be accessing. Right now, only stat works. These are just there for decoration. But there is one thing missing, and that is the buffers, as it says here. In order to pass arguments to this thing, we need to consider how to pass those arguments. Most of these arguments are some section of memory, a buffer. And most of these arguments are, we know the size of the, well, for all of them, we know the size of the buffer. Otherwise, we have bigger problems. Where is system module? Here it is. Okay, these are all the file system functions that I have right now. There's a few missing. We don't have mkdir. We don't have makefile. That's not a name. Is there a what's the syscall for making a file? I know the command is touch, but what's the syscall? It's not mkfile, is it? No. Linux create file syscall. I actually don't know what that's called. Create. Create. Oh, but open. Okay, it is open. Actually, you're right about that. Create is just open. Maybe I don't want that. Although, maybe I want to add it as an option to open, but I want to have it separate. And by default, you don't create a file if it doesn't exist when you're opening it. I don't know how it works internally. Yeah. Yeah, we don't have mkdir. We don't have moving, which is really just renaming at the end of the day. What other behaviors are there to a file system? We got opening files, reading, writing, closing, stat, readdir, truncating, mkdir, moving. There's usually like Linux had what does Linux call them? Linux character modules, something like that. Character device drivers. It's what I officially copied this stuff from. Symlinks. That's another one, yes. Although it's yeah. Like my original implementation of sys module, which was one of my first streams, mind you. This one came from doing one of these things. So the structure of how to do it, I copied off Linux, but I think I copied most of them. Poll is one that I don't have, for example. And stuff like tell. Which actually there should be, although maybe stat kind of works. Doesn't matter. Yeah, maybe some kind of tell. But anyway, the way that all of these work is they usually work with buffers. They use file pointers, which the job is going to need to be aware of. It's going to need a file descriptor. It's optional technically. Open doesn't use a file descriptor, it uses a path. Stat doesn't use a file descriptor. And readdir doesn't use a file descriptor, but it's okay if we still have a file descriptor type here and it's just empty, we just ignore it. Funnily enough, I'm adding it and the only job that I have is stat, which doesn't use the file descriptor, but it doesn't matter. Stat uses a string for the path and then an fstat object, which is an object used to indicate to fill in once we have stat information for this process. Well, for this file, I mean. Both of these can be considered as buffers. You wouldn't think of them as just buffers, but they are at the end of the day. A string is just going to be a null terminated buffer. In this case, it's 4 characters, right? Including the 0th byte at the end. And fstat is just a buffer of size of fstat. So, in order to keep track of the buffers that we have in this thing, we're just going to create a buffers type, maximum 8, although usually I like to define it as max job buffers. Maximum 8 buffers, which is more than enough, because the maximum we really have is 1, 2, 3. Read dir uses a buffer for the path, a buffer to be filled in, and a buffer to keep track of the offset, so you can call it if you need more information. You didn't provide enough memory, you can resume from where you started with this thing. Either way, maximum we have is 3, but we're okay with having 8 buffers using a sized pointer, which is just pointer plus size, so 64 bits each, 16 bytes. We should be good. That's something like 128 bytes total for the entire thing, right? See, this is the kind of thing, for example, that an integrated editor, I'm sure Emacs, actually, I know it has a calculator. I've seen it here somewhere. Did you do the calculator? Cannot split side window? Why not? I just want a calculator. Ah, there it is. 64 bits each, that's 8 bytes times 2 times 8 buffers. 128. That kind of shit is really, 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 really useful in a program like this. Again, this is what a terminal should have been. Emacs is what a terminal should have been. Or what the terminal should be. Anyway. And then we're going to use a size to indicate the buffer count. So essentially, when we create this job application, the kernel is going to be responsible for filling this in using the syscall that we were given, which right now it's only stat. So this, it's going to fill in 2 buffers, one for the path that we're going to be statting, and one for the buffer. And how are you going to handle that? All right, so once we get to the job manager kind of takes this job application, which is already somewhat serialized. It doesn't keep pointers directly to the thread that is requesting or to the process that is being requested. It just keeps process IDs and thread IDs. And so it does not it does not take strings and other pointers directly. It will take already serialized buffers. So the strings will be converted to the sized pointer, and the other things will also be converted to these sized pointers before it is given off to the job system. The job system does not care what the arguments to the job are. Even though it understands the kind of job that it is, it doesn't care about the arguments to that job. It just has a bunch of buffers, will create memory in the process, and it will get that memory from the process back. All right, so let's see. In the wrong folder. File system. No, it's not file system. It's process. Jobs. Job manager. All right, so the job application now has that stuff. Although, maybe for convenience, I do want the job manager to allow me to serialize these easily. Like, it takes already serialized data, but there's no reason why it shouldn't be able to serialize it for me. serialize string, just so I don't have to write a bunch of these things. I should actually be able to static inline it. They're just helpers. Inline. We're going to return a sized pointer, which has as the pointer the beginning of the string, and as the size. Using sizeof here can be dangerous because if I'm not mistaken, sizeof at runtime will give me the same as strlen, whereas at compile times gives me strlen plus the null byte. So I'm just going to use strlen for str plus 1. And probably better to hardcode that and do that conversion. So yeah, just a helper. How much memory does the kernel in OS use as of right now? It's limited to 512 megabytes. Not a whole lot. Actually, when I was working on the scheduler, I realized just how optimized it is. Let's put it this way. Maybe this isn't 100% accurate anymore, but thank you for recompiling the entire thing. Well, no, right now, actually, the launcher is not optimized, so let me not open the launcher. Right now, the only process running is the one that's drawing the thing on the screen. Right now, no process is running because I'm not using the input to move the mouse. I'm not typing anything, and there's nothing happening in the background. Now, if there was networking, which I have disabled here, it would be doing stuff in the background because that's how networking works. But yeah, the processes in the kernel like literally don't do anything if they don't need to. So most likely what's running right now is an idle thread, and a thread whose job it is literally to wait. When I move the mouse, it does actually do stuff. But yeah, it is very optimized in that sense. And frankly, I miss optimizing my code that much. Should do it a little bit more. All right. Just to continue doing some helpers, we're going to do a sized pointer helper for job serialize stat. It is going to take an fs stat and return a size pointer that takes as the pointer the stat, and as the size of an f stat. Okay, those are the two serializers that I need for my job manager for stat only. There's gonna be a few more. These buffers need to be serialized with an explicit size. File descriptors. Yeah, should actually be pointers. Yeah, I'll figure out how file descriptors later. I don't need them right now, so it's fine. This is a buffer. This is technically a buffer, so this is the only other kind. I could just write the helpers for them right now, but I don't really need them. Most fun part to develop the OS so far? The user space. All that had to do with user space. That's been the most enjoyable part. Mostly exploring that, you know? Because at the end of the day, any work that you do, even for multi-threading, is completely going to be opaque. The end user is not going to see it. Even I am not going to see it if it runs correctly. I'm going to see it if it doesn't run correctly, but I'm going to forget that it's there if it does run correctly. Like, even I didn't fully realize or remember or grasp that all my processes are sleeping at any given time if the user's not doing anything in the kernel. User space can do whatever, really. But I didn't realize that. So it leads to things being a little bit like less visual, whereas it's more fun to develop user space stuff, because also that's where you get to do things differently even more, like drawing windows, all that stuff. You think ARM has a chance of becoming a desktop thing in the future? With Mac, 100%. It already has. Definitely was the right choice to go. So I wouldn't be surprised to see that happening more and more. Yeah, I think so. No, I don't know if it has a chance, but I think it should. All right, stat. This is where we create the job. Okay, after we create the job, we're going to need to serialize. Right, I was actually going to do a little bit more. Just going to do a little bit more in the job manager. I want to serialize into the job application directly. So I'm going to need yet another helper. Job app buffer. Job application append buffer takes in a size pointer and a job application and a pointer. And if app buffer count is bigger or equal than max job buffers, then return. Not gonna do it. But again, this is a chance that is probably not gonna happen, and this is highly controlled code, so I'm not gonna print an error. I'm not gonna give you any failure state. It's just gonna fail silently. And then maybe that'll come back to bite me in the ass. I don't know. We're going to do app buffer count, pointer. All right. So yeah, you don't even need to return, honestly. You just need to initialize one of these and then call job application append buffer using the application and the buffer. Easy. So now I can do a 2-line of code call, although I do need to save the job application. All right, it needs to be called before create job. So, all right, job serialize string, and that string we have as an argument here, path. No, first we have to pass the application, and then we pass the path. And job serialize stat. First we pass the application, and then we pass the out stat. There. Now we've given the arguments to the function call to the job manager, but not yet to the program that's going to be receiving them. Let's see. I'm just going to get rid of this. Bye, C++. Won't miss you. Stat s into x. Path and out stat. Okay, so this is going to say stat 0 into 0, stat null into 0. The point is to make it not say that anymore. Stat null into 0. Good. Once we're done with this, it won't say that anymore. Okay. When we stat, funnily enough, we're not really... we need to copy the first buffer, the string, the path, and we need to create a new buffer for the fs stat. We don't need to copy the one that we were given. There's not really much of a point to that. Because the information goes from the receiving process to the original process. Whereas, for example, for a write, it goes from the first process to the second. Right now, it goes from the second to the first, so there's not much of a point to copying from the first to the second. But we do need to copy the path that we're going to be statting from. Anyway, in create job. The other thing, how did I was wondering how I did this. how am I choosing which entry point to do? I literally hard coded it. I was wondering, how am I doing that logic of like, depending on the job type, choose the correct entry point? I hadn't done that yet. All right, so going to do a void prepare thread t, and we're going to prepare this thread for handling this job application. Okay, so here we're creating the thread, and here we can probably save a little bit. Well, I don't know. I'll pass over whatever information we need. Yeah, okay, so we need a pointer to the process. That's proc. We need that here and here. Although this needs to be switched up. All right, but anyway, prepare thread using the job application, the fs owner, and the new thread that we've created. Okay. Then we have to select the correct entry point for our program. And if there is no entry point, then we don't do anything. Maybe we'll return a false here, so that we know not to continue with this. Okay. And here we switch on the application type, which Z is going to conveniently, oh, hold on, this is not a switch, bro. Which Z is going to conveniently populate for us. Thank you for actually doing that. Okay, if it's none, we're going to return false, but that's going to be for default. By default, we're just going to return an error. For stat, our entry point is going to be what we had hard-coded before. Fs, that's proc, exposed file system, stat. And then break. There's going to be some other functions eventually, which we don't have right now. Cool, cool. All right, and then we will need to copy those buffers over for our process to be able to access. So we're going to create some new memory inside of the receiving process, the one that's going to be running the stat function. We're going to create some special memory. If I'm not mistaken, there should be a concept of special memory, which is not cleaned by default, and we kind of need that. Yeah. Although this will give me a pointer. Okay. I'm going to need to calculate the total size of this memory, of all the buffers that we are given. So to do that, we just application buffer count I++, and to the total size, we will add the application buffers index I size. That is going to give us the total amount of memory that we need to allocate. we will allocate it into our process's memory. And we're going to mark it as special, which again, if I'm not mistaken, will give us blanking on the name of that thing. We'll make it so that this memory will not be auto cleaned up or anything like that. And if I'm not mistaken, that memory will continue. We'll have more control over that memory essentially. And it is marked as special, so it's separate from the rest of the memory of the process. And we have control over it, which is useful because it's memory that we're creating inside of someone else's process. So we can run code for them. Well, make them run code for us actually. What type of operating system? Is it a server one or a general one? Or any specific use cases? I do have virtual memory implemented, yes, and mostly a lot of it came from a pull request. Added a lot of complexity, but kind of necessary, but I hate working with it, I'm not gonna lie. Okay, so all the buffers are gonna go in here. I started out making this as just like a console-based operating system, which is like, for example, why the launcher looks like that. It's not anymore, it's more general purpose. Can it do server stuff? Sure, but it's not really meant for it. Although it also has headless mode now. Well, I need to check if headless mode is compatible with the new terminal. The real reason for having headless mode is more than server distributed. That's one thing that I want to do. And with this file system in userspace thing, we're going to be able to make the operating system distributed. And yeah, it's not really meant for servers because really the way that I am planning on using it, it's more so for working over the local network. Not really with the internet. So in that sense, does server make sense? If it's local, maybe, sure. All right, we're gonna go through all these buffers again. And okay, you know what? I'm not sure the structure of this data that I'm given here. So we're gonna print that. I don't know if this pointer is relative to the process that like if it's a virtual memory address for the process or if it's a kernel address. Depending on what it is, the way that we do the copy is different. I'm hoping it's kernel because that makes it a lot easier for us, but I'm not sure. All right. Our buffers will go to FF0AE000. Okay. It's not kernel. It's a virtual memory address. Now, we could load the process's memory, but there's no point in doing that when, if I'm not mistaken, I should be able to do an MMU translation. I'm just not sure if this has actually been assigned. I highly doubt it's been assigned. So maybe I'll need to do the allocation and assign it myself. I don't think this is doing any allocations internally. It is not. Okay. Okay, so what I did here is not actually allocate memory. What I did here is create or reserve some memory in the process's memory space, but without actually giving it any memory. Which means we need to give it some memory. And then we'll write into that memory. Okay, so physical address, buffers, I'm going to call it for physical buffers. We're going to allocate total size. In pages, we're going to make it a shared between kernel and process. And we're going to make it read-write. We're going to allocate a full page because we're not going to be doing allocations inside of that. If this was false, we would have a little header at the beginning, which I'm actually trying to get rid of, because the kalloc function, which is the one that allocates inside of a page, I should replace with my user space and kernel space allocator. Do you want to use it or just a learning project? It started as a learning project, but I'm hating working with Linux so far. I want to use it. Everything is so janky, and you need to do so much configuration. Might as well use my own janky and needs a lot of configuration operating system. Okay. To map this memory, okay, so we need to associate this address with this address, which I forgot how to do. Should probably be here as well, but try handle page fault does that internally. Here, it does an allocation, and then it does this mem set is useless, by the way. MMU map, probably. Let me see. Since I have autocomplete, okay, this is one thing that I really hate, and that I really like about Emacs. Going back in Emacs, I can switch between the buffers, like this. No, not like that. No, I technically did it, I just did it in the wrong window. I can do this to go between the buffers that I have open. Though it has a few too many. There's a bunch of, like, stuff that I'm not using there anymore. Whereas undo and redo, literally, like these undo and redo, like back and forward in most code editors, will take you to where the cursor used to be. It's like an undo of moving the cursor. It's ridiculous. Like, I move it here, here, and here. Boom, boom, boom. It makes using these buttons completely useless, in my opinion. Because, like, I'm gonna be moving the cursor around within the same function a lot. But really, I want to go back to the previous file or the previous function, not the previous place where the cursor was. Okay, yeah, it's just a map for KB, okay. I feel like an OS, like, will be nice for desktop because Linux userland is a hot mess since it's separated from the kernel. You get it, you get it, you get it, you get it. There's no reason why my userland shouldn't be physically separated from the kernel, but it understands. It was built with it in mind. So that's pretty useful. Allocate into the mm. Eesh, no, that's not how you use that. TTBR0, okay. The titty bro. Okay. The virtual address is buffers, and the physical address is pbuffers. The attribute index is normal. The attributes are read write, and the memory is user. So same attributes that I just gave it. Does it have any sort of tree to its undo system? Probably. It wasn't super accurate what I said before about the cursors. Like, okay, I have my cursor right now on line 44. I'm moving it to 43, 42. Now I'm doing undo. And it goes to 63. So there is some other logic to this, but I genuinely don't care to find out. Fuck right off. Again, my biggest issue with it is the same that I have with most of Emacs, except for this part. Unintuitive. Hello, Blurry Square. Oh, okay. Is this not... Where is this declared? System registers. I see. Do I really have to import system registers for this? I think this probably. Yeah. I need to include this file. Another thing that, by the way, my code editor is going to have, page up and page down are not going to go one page up, exactly one whole unit of screen. It's going to go function up, function down. All right. Which, by the way, should avoid the... Hey, that patent expired. The Microsoft patent on page up and page down behavior. And here's someone defending Microsoft. They have a patent for page up and page down, by the way. But somebody in 2008 was saying it's actually not that simple. Why is it not that simple? It's not for page up, page down functionality on a computer keyboard. It's more specific. Take a typical PDF or a Word document and zoom in by 200% and hit the page down. Does the document go to the next page? Do you care if it doesn't? Man, I don't care to read this article. I don't know what to tell you. They didn't patent the keys on your keyboard. They patented the exact behavior. You need to understand. Microsoft has done nothing wrong. Leave Microsoft alone. Alright, why is this giving me errors now? Incompatible pointer. Oh, yeah. I forgot to cast. U pointer. Okay, and what is your problem? Incompatible pointers. Oh, yeah, why am I doing that? Alright, not sure if this mapping is gonna work. Let's see. I think we're not gonna get to the print if it crashes. I mean, if it doesn't work. Our buffers will go to... Okay, good. So, this virtual page in memory has been given this address. There is one thing that is technically incorrect. And I'm gonna make a game in patent WASD behavior. Yeah, right? That is so ridiculous. Count pages. Eesh, this takes 2 arguments? I think the second argument is page size, but I'm not sure. Yeah, it's page size. Not sure why I made this function dynamic for like bigger page sizes. It's like ARM version 9 has 16 kilobyte pages, if I'm not mistaken. Maybe a specific subset of version 9, I'm not sure. But, okay, these mappings that we are doing, we want to do them like this. I smaller than num pages I++, where we're gonna want to do this mapping per page, but really it's all about just deleting what was there before, apparently. I times page size. Since we are guaranteed that this and this are continuous memory sections. It's really simple mapping, should be good. All right, then we're going to copy these buffers into the thing. And to do that, I'm going to use a pointer, next address, starting at the beginning of the buffer. I'm going to go through these buffers and copy them, memcpy, into buffers, no, into next address, which I think I need to cast to avoid pointer. Then, what did I just do? I'm pressing page up and page down. It's going between files. The behavior I was literally talking about Well, I said page up and page down should go between functions. That's how I want it to work in my editor. But I like that Emacs has a way to go between files very easily. Zed was like, oh, I'm jealous of Emacs now. Hold on, let me add that real quick. Page up and page down now move between files. What the fuck just happened? I was trying to move up here. Now it doesn't anymore. See what I mean when I say that Zed is becoming more glitchy? That is insane. Doing the same thing, leading to two different outcomes, is crazy. Okay, so we're going to copy from the current process's memory into the receiving process's memory the arguments for this function, which we've put inside of buffers. So we do application I buffers I pointer and applications buffer size, which we should maybe ptr, which also needs to be cast to a void pointer, ptr size, and then we are going to be passing it into, there's one more thing I need to consider, but I'll get to that in a second. Increasing the cursor that we're using to do this right. All right, the one more thing I need to consider is all these buffers are going to go into arguments for this for the receiving process. And the question is, can I just say first buffer goes in argument 0, second buffer goes in argument 1, or am I going to have issues with that? That would be the easiest way to do it by far. All right, first argument goes in index 0. First argument goes in index 1 because there's a file pointer, but that's an offset. And then the size of the buffer needs to be passed as well. Unfortunately, it's not that easy. I can make it a little bit more complex then. I just want to do this automatically. As I'm copying the buffers, I put them into the correct register. Okay, so the job application, instead of just using pointers for the buffers, it's going to use a new type, a job buffer. That is going to have the pointer. It is also going to have a boolean for explicit size, and it is going to have a U8 for arg number. We're going to have to pass that explicitly. So we say, is the size explicit? Then we copy our pointer into argument provided by this, and if explicit size into the next argument, we will point the size of the pointer. All right, so this is now a job buffer. Buff pointer. We will increase this by the buff pointer. And then into the thread is T, right? Thread is T, yes. The threads registers index buffer arg number equal to the address that we just wrote into. Simple as that. And if explicit size, buffer explicit size, the same thing we just did, but one forward, we are going to write the size of that buffer. This part we're not going to be able to test yet, but it's fine. That would be the buffer pointer size. All right, so we're already populating the arguments if we're doing everything correctly. However, I need to change this now into creating a job buffer. Passing that in as an argument to this thing. This is the sized pointer of it, but there's more information now. The pointer, this thing here. The argument number we're going to be given by this. And explicit size, false. Strings are null terminated, so we don't need to pass the explicit size. Stat has a specific size, hard-coded, so we don't need to pass that either. All right, so adapt this. You will also need an argument number. You won't need this anymore. And you will do this. Okay, what is left? Right, pointer size. Okay. That seems like all the boilerplate. Yeah, null terminated strings are annoying, but it is C, how C works. At this low level, I don't want the system to use string slices. Maybe I should, but yeah, I probably could. Just cannot be bothered. Maybe in the future I will. But right now I'm following the C convention for strings. Which is another thing of if nobody breaks it, it will always be like that. So maybe I should, but I cannot be bothered right now. Anyway, with that, I need to make some changes to the file system now. The call for stat, first argument is the path, second argument is this, so we will need to tell it. The path goes in argument 0, and the stat goes in argument 1. Whereas, for example, if we needed to pass the explicit size, then we would just do this, and it would know already to pass the explicit size, but we would need to keep that in mind. All right, if I did everything correctly, this stat null into 0 should have an actual value, even though it still won't do anything because there's no code there. All right, it's worth seeing. It crashes. I figured as much could happen. All right, it's crashing the job manager 55. Mem copy. Of course, system crashed because this argument doesn't map to anything, but then again, this is the oh no. I'm supposed to copy to the physical buffers, not the virtual buffers. The virtual buffers will work inside of the process's memory, but right now we're not in that memory, so it crashed. Although it crashed in string.c, so I did something wrong. But what crashed is... Boy, is it beautiful to see this red. It means I deleted C++. What crashed is the string printing. So that's wrong. But there you have it. Okay, we have actual values. They're just not correct. I am using the... yeah, that's my bad. I need to simultaneously, I guess, use the virtual and physical address and keep them in check. I copy into the physical address, but to the process I pass the virtual address, and then I have to keep them both up to date. Those are still the wrong values. Oh my god, I didn't actually update this one. I think it's time to rewrite this in Rust. Don't make me pull out the main function. There we go. Stat. These look like the virtual addresses that were being told here. Except they're truncated because of the way that I'm printing them. But it looks correct. The main function in question, by the way, POV, you're writing a Rust operating system. How do you do a main function in Rust? Hold on. Let's do that properly. What the fuck is that? Result for a main function. Man. Nah, it's not even worth making the joke. This language fucking pisses me off, I swear to God. Seriously, so annoying. It's such an annoying language. It's such a pedantic language. Alright, ad starting in 25 seconds. Let's speed run this. Let's outrun it, actually, and see, will it print my string? No. That didn't work. Alright, ad starting, so I'll be back in 3 minutes. It did not access the memory correctly, so I am doing the memory mapping wrong. Shocking. But yeah, Rust couldn't really handle this well. It would require so much permission to do memory mapping. It doesn't work like that. I'll be right back. We have returned. I love that there's just a dog head off there in the corner. Barely visible. Okay, I've had like 50 coffees today. The one I had at the beginning, then a second one, then a third one, and it turns out there was still a little bit left. Then again, super weak coffee. It doesn't change the fact I've had like 50 coffees today. Maybe if I didn't have 4 coffees an hour, I wouldn't have run out of coffee so quickly. Okay, it would look like something's going wrong in the memory mappings because I'm copying memory into a process and the process is not reading that memory. It's not accessing that memory. But once we have that, we will officially have a job manager that synchronizes data between 2 processes in an asynchronous manner. 2 worker threads. Well, 1 worker thread and 1 that requested the job. I guess that's the boss. Or that's the client. So it's more of a freelancer thread. Or a consulting thread. It's more of a consultant because it belongs to a process. That's where it actually works. But it's being given given work by someone else. So it's a consultant. Going full LinkedIn with this whole job system. Anyway, maybe this is failing. This returns void. First off, am I passing the right process? You prepare a thread, yeah, with the receiving process. We're creating memory for that process to access. And yet, it says that oh wait, hold on. Okay, hold on. It's trying to access this. Yeah, sure. Unknown fault, according to my system. Really, it's a address size fault. Address size fault. What does an address size fault mean? So there is a valid mapping. There is an actual mapping happening. The memory is accessible, but it is creating an address size fault, which I don't understand what that means. I mean, kind of. I don't understand what this actually is. Address size fault. When we're talking about a string, which is being read per byte, unless the memory is corrupted somehow, and so it feels like it's not being read per byte. So let me try to do this. Print the address and the path. And the size, I mean. It crashes without printing this thing. Very quickly after beginning the process. So this is the entry point. So this is the beginning of the function. And this here 40D4, very similar to that, is where it's crashing. So probably here somewhere. Because of this address and still unknown fault, which is an address size fault. And I don't understand what that is. The address is valid, but it's an address size fault. Okay, let me see the actual instruction. This one. Load register byte. Load register byte immediate calculates an address from a base register value and an immediate offset. It is happening inside of strlen. One of these, probably this. Can I then inspect that memory? Let's say the first 256 bytes should be enough. And I just want to print the contents of that memory. No. I first tried to learn C, my program kept faulting for no reason. Turns out one of my RAM sticks had gone bad. That happened to me with the first time I tried to make an operating system with a Raspberry Pi. Yeah, the Raspberry Pi was faulty. So, never understood when my code didn't work until years later I tried to use it for something else and it was like, oh shit, that's why it didn't work. None of this printed. I don't... It's the same exact error, but now we're not doing strlen anymore. We're trying to access the data, and it somehow is leading to a fault of wrong address size, which I don't understand. Address size fault. What does that mean? It's clearly a memory configuration issue, because I'm configuring memory and I'm not doing it right. Do we do anything special for special memory? Like, what happens if I try to register as anonymous memory? Will this work? No. Same exact issue. What if I try to register it as... Yeah, it's nothing else. Special, anon, or... Weird. Hi, Ice Dave. Thanks for the link. Faults and watch points. Okay, so, it was a what? An address size, right? Address size fault, okay. The translation of a virtual address to a physical address might generate an address size fault. Yeah, but why would that happen? It's not very clear. That's all we have. Points to physical address F80047F51000. That is the same address, although... Is it missing some F's here at the beginning? It is missing some F's at the beginning, but that's an ARM thing. Well, yeah, I understand what I'm doing. Okay, I understand what I'm doing. When I do a palloc like this, I should be doing a palloc inner with no mapping, if I'm not mistaken. Yes. Because the address that palloc returns is a kernel address, which has that FFF at the beginning, which puts it in kernel memory, which is virtual address in and of itself. So we're trying to resolve a physical address, no, a virtual address to another virtual address instead of to a physical address. Never seen that error before. I feel like there's probably a better way to put that. Why did it freeze? Okay, something changed. That's kind of good. But the physical address is now not mapped. The physical address is not mapped. So I need to map it. Though it should be possible to just MMU, wait, hold on. Just do what the palloc is doing internally for mapping. See, palloc is doing this. Although it also needs to map it. So do that. Register proc memory, isn't it? That's an inaccurate name. But yes. Oh, let me see how the process loader is doing it. Because you are doing it here. Yeah. I need to do this translation. Well, no. This is just a translation. It's not mapping anything. But yeah, okay. Now I have a physical address and a virtual address for the process, but I also need to get a virtual address for the kernel for this thing. To do that, MMU register proc memory should be enough, where the address is this one. but using p buffers and also doing a fizz to vert to get the virtual address that we're going to be mapping to. Then the physical address is this one. The memory is again read write, and the access is mem priv kernel. Okay, so now the memory is accessible to both of them. I use the kernel's virtual address to copy, but then the process's virtual address to paste. Well, that did something. Doesn't crash anymore. It also doesn't do anything anymore, but it did something. Okay, not sure what the hell I did here that completely crashed everything, but there we have it. There we have it. We're being asked to stat term history into this thing. Although term history is not the correct value, we need to advance it. There's some missing stuff for the kernel, for the file system to handle. Isn't it? I believe I need to pass the search path, not the path. Because it's supposed to get rid of the term history part, because that's redundant when you're already inside of the term history module. There we have it. Stat empty, because we're not doing a subdirectory, we're just doing something. We're just doing root, so empty, makes sense, into this value here. And can we fill in that value? We should be able to fill in that value. All right. This is working. Yeah, I'm surprised. All right. There should be a stat dir helper function that handles this for me. I just have to call that, and that will fill in that information. Just want to see that it doesn't crash, but it's still not going to get back to our process. Good. Good. Okay. So, at this point, one process has requested information, has been forwarded to the correct process. That process has filled in that information, but we have not copied it back to the first process. We have resumed the first process's execution after blocking it, but we haven't given it the information back. That is another part that is currently missing. However, maybe it's time for a commit. Just want to quickly see that everything is correct. Zed, you glitchy fuck. I am trying to do a commit inside of this repository. Why do you switch it? God. This is not the diff. This is not the diff to that repository. This is the diff. I like to look at the code that I'm committing before I commit it. And Zed makes it really complicated when it glitches this much when doing a simple commit. And again, this is just going to get worse if they're really just vibe coding, which is this completely directionless system doing this thing that only has so much context and writes so much slop that it will overwhelm its own system, its own context, essentially. Job buffers. Let's do it like that. Next, Linus Torvalds is being created, making an OS, wants his own tools to make his own OS. Not even that. I don't care about other people using it. That's just something I'm doing for myself. Job copying buffers into worker. Into the worker. Now we'll need to do from the worker, get the response back to the original process. It's taking so long. My Git server timed out for a bit, so that's not great. Then it worked. Oh, the computer's a little bit old. Anyway, at least I have my own Git server now. As you see how all software is becoming so janky. That is the main reason behind making your own things. Is it janky? Sure. But first off, when you made it, you understand the jank more. Second, it's kind of less likely to be janky because you control it and you made it custom for yourself. So maybe Z is glitchy when it comes to working with multiple processes because the LLM, well, let's assume that it's not being done by an LLM, right? Let's be unrealistic and say that it's not being handled by an LLM, it's being handled by a human. But the people who work on the Z team don't work with multiple projects at the same time. So having a Git client that can handle multiple processes, multiple projects at the same time is not their top priority. Whereas if I'm making it and I work this way, I'm making software that works in my way. Maybe if you use the software and you have a different workflow, my software won't be as good for your needs, but it's not a commercial product, so we're good. We're good. Okay. Okay. So, current workflow. One process hosts a file system. Another process wants something from the file system, requests it. The kernel realizes that it needs to forward it to this one, takes all the arguments, copies them into this one's memory, calls a new worker thread into this one's memory, blocks this one's execution. This one executes. When it's done, reports back to the kernel, or the kernel realizes that it's done executing, reports back, and the part that is missing right now is the kernel needs to tell this process how the operation went, so the actual return value, and it needs to copy the information back to the process. Right. So few steps to doing that. As a matter of fact, the file that the information that's being filled in is literally empty because the file that it's asking for is a directory, not a file. And so it uses entry directory, which, oh no, it's type 2, so it is supposed to have a value. Okay, never mind. But its size is 0. So I'm wrong about it being completely empty. It should have a 2 here, but a 0 here. But the really important part when it comes to the file browser is this return. This is how the file browser is like, hey, you can actually access this folder. Otherwise, it's going to be grayed out. If it returns a false, it's going to be grayed out. If it returns a true, it's going to be, probably it's going to work. Maybe it's going to be grayed out unless this is filled in with the correct information. Like if the entry type is invalid, it will also gray it out. I'm not sure. Let me see real quick. Oh, the file browser is actually a header util. It is a header only kind of library that handles all the UI stuff. So I can integrate it into other programs. Maybe if I do stuff in an Emacs kind of way, I won't need this complicated setup. I guess we'll see. Probably won't, probably won't. Or I can simplify it a lot, get rid of the visual part of it, but I guess we'll see. I like being able to embed applications into other applications. Like this header file acts as its own application, and then I can embed its window inside of another process's window. Anyway, when you call stat, here it is. Okay, if no stat, it will print an error. And then, yeah, it should be able to handle. It should be able to handle. Yeah, I think it will. It is not prepared for an invalid entry type. It will consider it to be just a generic entry type. So just having the return value is going to give us a lot of information. And we don't need to do much for that. We just need to save the return value, which is simple to do. Wrong syscall file. Here, halt. Okay, when the thread is halted, if the thread has a job ID, the job is considered fulfilled. We will need to pass the return value to fulfill the job, which is always going to be a 64-bit pointer. Oh, 64-bit value, be it a pointer or an actual value. See why it's cool that everything is in the file system? This whole job system is so standardized to work specifically for files and folders that it allows me to make it have very specific behavior. So I don't need to handle edge cases to a generic behavior or anything like that. It's super simple. Anyway, the return value here is this one. There is a return value. And the job manager, when the job is fulfilled, it will get the requester and set its thread state to ready. Sure. But also, requester proc x0, this should work, ret. Okay. I could have done that a long, well, no, maybe I could have done that a long time ago. You can see that the code for it was relatively simple. Just, we already have the exit code and we already have the place where to put it. We just have to connect the two. So maybe I could have done that a lot sooner. What was that noise? Like something fell. Thread has exited with code 1. This is still gray, but I'm not seeing fail to get information. So I think it worked. I think it's just gray because, like I said, this can happen. Kind of makes sense. An invalid entry, this whole like color code, an invalid entry is going to be gray. Just don't remember the exact logic that I wrote for that. Do I have the colors anywhere? Entry invalid is this one. But Oh, that information was never filled in, so the entry is considered invalid. Okay. Makes sense. Okay, but the error went away. Just to confirm, let me not save the value. See the error in the console. I'm not seeing the error. That's... Or actually, explicitly hardcode the error to false. No, I'm not seeing the error. That's why I'm not seeing the error. No, we're in the main thread. We're in the main thread, so that's not it. I'm not sure what's happening. Oh, wait. There's one more thing. I still didn't change anything. Unless I'm expecting to see an error here that I shouldn't be seeing. Like that is not actually programmed to give me. Alright, this is where it calls stat when you enter a path. And also when you refresh, if I'm not mistaken, just stat as a function. You call it here when you do on entry. Okay, yeah, I think this is the one that is being called, and like there's no failure state. So I'm looking for an error that doesn't exist. There's no failure state, so this makes no sense. Alright. Failed to get resources, disk, graph, audio, tools, and in. But it didn't fail to get the one for term history, which I'm hard coding to fail. And I'm also making sure that we never return. And even if we did, we would return a false. Term multi-threading in Python. Yeah, I heard that multi-threading in Python is just sequential threading. Kind of like it works on this system because I don't have multiple cores, but come on, that's ridiculous. On an operating system that's under active development, it kind of makes sense. On an operating system that is, I mean, on a programming language that has existed for a really long time, why would you do that? Not understanding what is happening. I mean, succeeded stat for s full path. I mean, term history is going to be here then. It's succeeding somehow. Term history, succeeded stat. How did you succeed? How did you succeed? It's literally not even returned until here. I think the process is maybe not being blocked properly. Yeah, this is not working. This was working yesterday, right? What happened? The thread that is requesting this is getting blocked. But it's not. It's continuing its execution. So it somehow returns true, which is inaccurate. The reason it returns true most likely is because it's wrong. And like, the return value for the syscall is being placed in register 0, which is also where the first argument for the syscall is. So because I'm doing something wrong, the argument is being passed as if it was the return value. It exists, so that's considered true in C, and that is causing it to just continue execution and thinking that it succeeded at... Now it didn't succeed anymore. But again, you should not be continuing. When you get to this point, your process should be blocked entirely. So what am I doing wrong? Do I need to also block the process? Again, the scheduler is like mid refactor right now, so yeah. Alright. Right, so I need to block the process. And then I need to like get the process back. So I can unblock it as well. Okay, and the scheduler right now is halfway between working on processes and working on threads. So this kind of thing is, I guess, a little bit expected. Okay, but it didn't resume execution. Although, it is being blocked correctly. I need to ready the process now. Put it back in the queue. Nope. Oh my god. This was working yesterday. What happened, I wonder? I didn't need to do this whole process thing yesterday. I was working perfectly fine. And what I did now shouldn't really affect that. No, unless I need to mark it instead of ready as running. Okay. But it's... Now I'm confused as hell. Because it's almost correct, but these logs are in the opposite order. It says it failed the stat for term history before it even tried to do it. But it's so close to being the correct value that you would think it worked. To the correct order, whereas before it was super out of place. Okay, this is weird. If I don't resume the execution of this thread, the requesting thread, then if I don't request the execution of this thread, then I never get any results on the current thing that I requested because I never came back to the process after requesting it. So far, so good. But if I restart the process, then I get the result before it's actually calculated. Wait, this is why I removed this. That actually stops the execution of the current process, because otherwise we could return to it very briefly, even though it's supposed to be blocked. Okay, now the process is blocked. So I go to the job manager and I ready it again. Okay, that is correct behavior. All right. So, yeah, we failed to get this one, whatever. Eventually, we try to get information for term history. The job takes over, blah, 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 blah. Job gets fulfilled. We return to our process, fail to get it because we hard-coded it to fail. We can now hard-code it to succeed. Let's see what happens there. Succeeded for term history. That's very good. And finally, just use the actual return value, which is a succeed, but yeah, we're good. 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 Okay, so now the second part of this whole thing. First was getting the return value. Second, copying the data back into the correct buffer, the one that was actually requested instead of the copy that we made. Then we'll need to clean up the copy. We're not doing that right now, but that doesn't really matter right now. Let's just take it one day at a time. Okay, job. Here, a job buffer has a worker pointer, but it also needs to have an original pointer to know where to paste it in. Is my channel live from day one? Not day one. You're gonna have about a month or two worth of VODs and some YouTube videos before that. But there is some more stuff on my YouTube channel. Yes, you'll find that. We will need to keep track of each buffer that we wrote. Do we need it? First off, no, let's not make this let's make this an enum. Copy on start or copy on end. Sync. Okay, so do we need to make the copy of the buffer when we start or when we end? That is thing number one we need to take care of. And thing number two is where do we copy to and from? Yes. Okay, so this is no longer just a pointer, it is the worker pointer. Now, this memcopy only happens if buffer sync equals to copy on start. Okay. What else? The worker pointer. We do need to allocate enough memory for all of these buffers, but in some buffers we're going to need to copy them when we begin, such as like the path for the argument, and some we need to copy them when we're done, such as the result of the operation. Both of which are buffers, so we'll need to handle that. Okay. For the worker pointer, and for the original pointer, we will just copy them directly. Let me calculate strlen once. All right. And then this is a stat with, again, a hard-coded size. The size of is actually resolved at compile time, so I'm okay with copying it. It's fine. Now, the sync behavior for stat is copy on end. So we won't perform a copy of an empty buffer that is being provided in order to fill it in. But once we're done doing it, we will copy it back to that empty buffer so that the requesting process will have access to it. The entire point is they provided us with the memory to use for this operation. Even though we used other memory, they provided us with this memory, we're going to copy for it. Strings, on the other hand, for now, I'm okay with hard coding this. Maybe eventually this will change. But every time we use a string in a file system operation, it is used as an argument. These here are not actually strings, they're buffers that are char. That is where the actual file is going to be, and that will be a different story, but we're not handling those yet. So for strings, we can hard code the copy on start behavior. Okay, so the argument is going to be copied over. A buffer will be allocated but not copied. The terminal will fill in that information. Then that argument, that buffer, will be passed over to the original process. Okay. To pass it over to the original process, I'm going to stage because I've done a fair bit. To pass it over to the original process, we will need to, when we fulfill the job, get the job state. Oh, am I copying them over to the job state? I think I'm not. Yeah, the job state is not keeping these buffers, so needs to do that. This information is not being maintained by the job manager itself, so we'll need to pass this over. All right. Each of these buffers gets copied over to the job buffers buffer job buffer count plus plus equal to buff. That way we copy them over. All right. Then, when we receive them, they don't come from the application anymore. They come from the state. Okay, we'll get the buffer. And if the buffer is marked as copy on end, we'll print for now, copy buffer x into x. This will be both virtual addresses for each process, so we'll need to resolve that. That's gonna be very fun to do, but it's fine. How we do that? Well, no, actually, we're guaranteed once we're here that the source buffer to copy from is already in memory and accessible because we're currently in the worker thread's memory. So that we have a guarantee of. We don't need to resolve that. But in order to copy it over to another process that's currently not executing, we do need to resolve to a physical address and access that. But either way, we're going to copy from the worker pointer to the original pointer with the size that we've been given. We're going to copy from... That's not accurate. Good thing I did a print, because these are the same address, so I must have done something wrong. Job manager. Ah, yeah. Wait. Ah, okay, here it is. Job buffers I. Well, no, actually I do need that. But job buffers I worker pointer is equal to this thing. Whereas the original pointer is just getting copied over. Okay, so now this address is going to be resolved to this address. Okay, I think those are correct values. Cool. So here we will need to do another mem copy. The destination we're going to need to resolve, but the source we already have. It's this one. And the size we already have. It's this one. What we need to do is resolve this value. And once that is done, everything will be done. We will need to get the address by doing an MMU translation for the current processes. Well, not the current processes, but like the target process, the one that did the request. MM memory mapping TTBro, which stands for translation table. I don't remember what it stands for. Whatever. The virtual address is the buffer original pointer. And this will give us a status. And no, what the hell am I trying to do there? If no status, then I'm going to print an error, but there's a chance that this is not a proper error. There's a chance that I'm gonna have to do an MMU. No, I can try to do it. Hold on, let me do like uaccess has code for that I can copy. This pretty much. Okay. It'll try to handle a page fault for the ST requester using this address, and it will try to do the translation again. And if this happens, it will just return. And if this happens, it will just return. But these should have already been checked, so I highly doubt this is going to happen. But since I already have the code, might as well. It's essentially handling a page fault, which we can be in a situation where the memory has been given to the process, but hasn't actually been mapped for expediency reasons. We just promise that we're going to give you some memory, but we'll only give it to you once you actually need it. That's going to be this case. So this is checking for that. And the address is going to be saved here, and then we're going to do phase to vert for that address. And that is going to be converted to a void pointer. So is this, I did the conversion wrong. Okay, all the code is written, the logic is there. There is an add starting. So cliffhanger. That way nobody leaves. We'll find out if this whole thing works, and if I've literally finished the entire thing for stat, then I'll need to implement it for other functions. In 3 minutes. I'll be right back. Here we are with the resolution to last week's episode, or 3 minutes ago's episode of Does My Code Work? Have you ever tried Odin? I have written a very little bit of it. Very, very little. Just a simple, not even a hello world, just a little thing that they have on their website. Hold on, yeah. Wait, what do you mean remap conflict? Um, yeah, I'm starting to see a problem here. Uh, I believe this was supposed to be if status. Yeah, if status. So I did if everything goes right, map the page. So that was creating a conflict. Okay, for Odin, I have written a little bit of it. Boom, term history has data now. Look at that. Look at that. Look at that. It's blue. It's blue meaning it's a term. It's a folder. We got information back from the other process. We're communicating. We are communicating over the network. There's no network. We're communicating over the kernel. We have inter-process communication. Lord help us, we have inter-process communication through the file system, which also for free gives us file system and user space. Really, it's the other way around. File system and user space gives us inter-process communication for free. That's what's really happened. All right, holy shit, it works. First try too. God damn, I'm so good at writing memory management code. Who needs Rust? Rust would actually get in your way for this kind of things. Because you're the one managing the memory, not Rust. You can't let the programming language handle this. Anyway, for Odin, the thing is, a while ago I tried a bunch of programming languages, and when I was listing which programming languages I want to write, I saw something in Odin's website, which I really liked. This little program. It is kind of a virtual machine, if you will. It's a very, very simple version of it, where you have a program using the string and an accumulator, and then depending on the program, you perform a different operation on the accumulator. You add to it, you subtract from it, you multiply, you divide, you multiply by itself, and you ignore everything else. So I wrote this in a lot of different languages. So let's see them in Emacs. See what that's like. Close that. Close that. Close that. Why are you not closing it? Whatever, man. I'm done trying to understand how this thing works. So I wrote that in a lot of different languages. Here it is in C. Here it is in COBOL. Here it is in Rust. Here it is in Gleam. That was a genuine mistake, by the way, because it's called Krusty. Here it is in Gleam, Go, Lisp. My first Lisp. How quickly they grow. My Lisp doesn't look like this anymore. Looks good. Jules, Nim, and Odin. The interesting thing about Odin is when it actually came to writing Odin as a language, I could have just copied and pasted this thing. But this is literally all the Odin that I have written, ever. And it's literally not copied from the website because I tried not to look at the reference, but it is literally word for word what they have on their website, so that's not super helpful. But yeah, I have seen some Odin. It looks okay. It looks like a fun language. How long have I been writing this OS? A year and a couple months, I guess. April last year. Okay, this is monumental. We have inter-process communication in the kernel. No, not in the kernel. My god, can I learn how to speak? Can I take any like classes where they teach me how to speak like a normal fucking person and not saying just whatever and hoping that it's coherent? Because I could use that. I could use some of that. Okay, we can do stat over between two processes. We're statting between two processes, but that's literally all we're doing. However, I think I've written the whole thing simple enough that I will just need one more helper, and I should be able to do this properly for other things, such as read dir. The one thing that's missing is serializing a buffer. For serializing a buffer, we just take the buffer first. That's thing number one, the pointer to the buffer. Number two is the address to the buffer. And number three is the synchronization type. Which I should have probably typed deft. Okay. Another thing that I really don't like about code editors is how they handle these tabs. Like, most of them are considered kind of ephemeral. Like, you open it and then you open something else. Okay, no, it feels inconsistent. There is logic to it, but it's not the most easy to follow logic. Essentially, when I open a file, it is opened with this, like, you can see it's kind of tilted like that, say like italics, which means if I open another file, it will overwrite the current file. If I double click it, it will stay open. And that, when I'm not really thinking about how I open the file, will mess with my perception of open files. So that kind of sucks. And yeah, I find it not the easiest logic to follow if I'm not super paying attention to how I open the specific file. And I still always end up with like a ton of files open up here, so not much of a point to it. Okay, when we're serializing a buffer, we will take the buffer, the explicit size of the buffer, which has already been checked and sanitized, and the type of synchronization that we're trying to do. So that goes here. Buff. This should be size. I don't know what adder is supposed to be. We don't need this explicit size here. Let's call it pointer. Okay. Architecture, ARM. ARM 8 specifically. Okay. That will allow me to implement, with relatively little code, the same thing for... Actually, can I metaprogram this? Yeah, I can metaprogram this. Can I even do it directly in the job manager, maybe? Job make with a type. Type is going to go here. And a little bit of escaping. See how ugly this is? Don't you wish you had Lisp to metaprogram in? Ah. There we go. I can't really escape a comment because that escapes the comment that makes everything else a comment. So, not sure how I'm supposed to handle that properly, but I'm okay with moving it outside. And here I do job make, job stat, and then I actually wanted to have the serializing needs to happen inside of an action block. So type action. We're going to put the action here with a little escape. And there is our action. And what is your problem? Job stat does not... did I not call it job make? What did I call it? Job make. Ah, but it's called type here, so... that hopefully fixes it. There we go. It's now that easy to do this kind of job. We'll need to introduce a few more. Read, write, truncate, see, the file that I need is not open right now because I struggle to understand like to keep the files that I actually want here. I understand I'm supposed to just pay more attention to how I open them, but come on. Open a file. That one's missing. That one's a pretty big one. Job open. So we're not actually implementing these because these need to deal with file pointers, and I cannot be bothered with that right now, to be honest. It's not super relevant to what we're trying to do. Well, it is, but not right now. Read, write, close, stat, which we've already done. Read dir, which is what I'm really trying to do, and then truncate. Okay, so all of them are here. Last one's missing is job read dir. Which, guess what? You don't need to open a directory to read it. That's stupid. It's a stupid thing to have to do. All right. I'm still going to comment most of these out, but at least I'm listing them. And in the job manager, I'm going to introduce a new case for job read dir. The entry point to that is going to be the processes exposed file system read dir function. Easy. Cool, cool. And the final step of that is to do this same thing in the read dir function, where it says cbarn. We're going to be doing job read dir, and the arguments that we pass are a path, a buffer, no, which requires a job serialize buffer. I'm going to learn how to do such stuff myself, not just vibe coding. Nice. Happy to hear that. Wait, hold on. I missed one message. During the last couple of days, I've used Plus Code to vibe code a simple OS. It is Unix style and have a thin Linux compatibility API. Even run muscle-linked UseBox utils. I'm surprised that LLMs can do that in the first place. Okay, using a job application, argument number. This is where that comes in helpful. There is one argument that I forgot to pass in here. When you serialize a buffer, you specify the argument number and then you specify explicit size. So that goes here. Because here I do need to pass the explicit size. Argument number 0 is going to be the path. Argument number 1 is going to be the buffer. Argument number 2 is going to be the size of the buffer. So 1, true, then the buffer itself, which is going to be Up there, buff, size, which is going to be size, and job sync is copy on end, because we're reading. So the process that has the file system is we're going to be copying from the process that has the file system to the process that is doing this request. And I need one more helper. For file offsets. File offset is going to be using a file offset the pointer is the size of that, which is just a U64, but still needs to be copied over. Copy on end, because it's a read operation, and no explicit size because we already know the size of it. We don't need to pass it to the process. Okay. So we are now going to be using this one. Application. Argument number is going to be 0, 1, 2, 3. This is actually the one that has the most arguments. And the value of it is offset. Okay, time to see if this works. I'm a little scared. Another thing that I'm scared by is that every time that I move the cursor in the file browser, it refreshes. So all of this is doing, yeah. All of that is doing operations on the file system, on the terminal. There's a limited number of stacks that you can have, and I'm not cleaning them up and reusing them, which means I run out before I get to the bottom of this. Fuck. And really the only thing that I'm able to do here is to not stat every single time. Just for the sake of now, like this needs some cleanup obviously, but okay. I am able to enter, but it didn't work. It did not work. It did stat, and it fulfilled job 1. Did I pass it the same entry point by any chance? Did I do that wrong? Read there. That's the entry point. Okay, I'm not sure if read there is working. I mean, it's not working because it didn't give me any data. Custom read dir. We're going to make you a size t. Custom read dir. That's going to take a const char path, a void pointer buffer, a size t size, and a file offset. It's going to print read dir. It's going to return 0 though. That didn't get called. I am telling it to read dir, which by the way feels weird to not put a semicolon here, even though it's not strictly necessary. Which distro do I use? Hannah Montana Linux. All right. job debug will happen with job 2. All right, how about we print which one is actually being... Sorry to interrupt, but how long have you been working on this? Do you mean the multi-threading? Started it last week, but really the implementation yesterday. And if you mean the whole operating system, about a year, a little over a year. Wait, now that I think about it, where am I getting the current operation from? Application type. Okay, that's what I want. Okay, so did I do that? Did I do everything I need? No, I think I didn't create the terminal. No, I did. There's the history. Okay, I haven't actually opened it. It's the thing. Okay. The job type is 2. 0, 1, 2. Read dir. That seems correct. All of it a year. Although it says it's gonna do job 2, it creates a stack for it. It creates the buffers for it. It schedules the 3rd thread. Stat. Somehow we're still ending up with stat. Stat is being called for this process, not read dir. Even though application type read dir entry is read dir, there is a break, so there's no fallbacks or anything like fall throughs or anything like that. I'm actually using the entry point. I'm not, am I? I'm not using the entry. Oh my god, I'm not using the entry point. As soon as I figure out where the entry point is supposed to be, here, it's hard-coded. Lord, it was hard-coded. Okay, so read dir was called. But of course, read dir does not have the correct information anymore. So I overrode it. The correct read dir is stackfs read dir. For that matter, the correct stat is a different one. Crashed. Cool. Well, that's a new crash too. What the hell is this one now? I've never seen this one before either. Oh no, hold on, it's just a translation fault level 2. But it doesn't have any more information of what crashed. Just all we know is that the terminal crashed. Looks like it, but yeah, it's not working anymore. All right, back to the terminal, back to the custom read dir. Okay, tell me, read dir s with the path into this buffer with this size and using this offset. Buffer, size, and offset. Let me see that all of these are being copied properly. Read dir empty, although empty is correct. Empty is the correct value to use there. Into a buffer given a whole page of memory using, I did the print a little wrong, so now it's a little bit hard to tell what's happening. AD001. Okay. So, yeah, it's not super accurate necessarily, but it should be fine. Since I'm putting all the buffers in continuous memory, I'm allocating a whole page of memory to fill in with this information. But that page is being put 1 byte into an actual page simply because the byte belongs to the null terminator for the empty string going on here, which just means read the root directory. So I don't think that's incorrect necessarily, but something is going wrong. Right? If the whole thing's crashing, there's got to be a reason for that. Okay. Hello, King. What's up, King? All right, doing the custom read dir. Okay, we're good. Now try to read size t size equal to stack fs read dir, passing an empty path, a valid buffer, a valid size, and a valid offset. They look valid to me, and then return that. I see. All right, let's see how that goes. The process crashes. I couldn't really tell you if the crash has to do with this. I'm gonna go with, yeah, probably the crash has to do with the actual read dir function, because it is a bit of a function I haven't super bothered with. But what I'm gonna do is I'm gonna try to hard code behavior here. So I'm going to hard code some files with this helper with list directory contents. How do you do this again? There's a lot going on here, so very likely that this is the cause of the crash and it's not the actual system that I'm doing. Dir list fill. Okay, that's what I want. Helper with test. Okay, so we're gonna give it a value. We're going to write a file or something called test. We're actually not specifying what it is, but something called test in this directory. And that is the value being written. No, that's the limit. The offset? No, I think there's something else I need to do. Dir buffer size. That's what I need to return. If the problem is in the stack fs, well, I'm gonna be using that a lot more if this whole thing works. So I'm gonna debug it then. Okay. And no matter what, yeah, eventually it will have issues. Like I said, we're not cleaning up all the memory, so it's not infinitely recursive. But every time you do a read dir anywhere in this directory, it tells you that there's something called test. And every time you do a stat, it tells you that there is a directory. that whatever it is a directory. So test is always a directory that contains tests infinitely. But I have a file system in user space. Read there works. Now, I'm going to have to figure out how to do, not sure why my eye is itchy there. I'm going to have to figure out how to do file descriptors, because file descriptors have yet another thing about them. The way the file descriptors work is a file system module, such as the one in user space, will have its own IDs to refer to files. Right, so ignoring the kind of recursive nature that this file has, test, let's imagine that it's a file, is going to be ID 1. So from the perspective of this file system module, talking about file 1 means talking about test. However, that is kind of considered a global file system descriptor. When it comes to instead the client, the process that is requesting this thing, it is going to be given an instance, not ID 1, but maybe ID 235, which simply indicates file system open operation number 235. It doesn't have to necessarily specify that there's been 235 file system operations before it. It doesn't necessarily mean that. It means an instance of this file. You open the same file twice, you're going to have two different file systems, but the module that owns those files is going to have the same ID for them. So there's a bunch of mapping going on there that the kernel handles, and I will need to port that to this whole system before file system, before I'm able to implement open, read, write, truncate, and close, because all of them work like that. So essentially, your file system will give me a global ID. I will take that global ID, create an instance ID, and return that to the process. And then when the process uses that instance ID, I will translate it to your global ID, and I will use that for you. It's just very basic translation. It's literally already in the kernel. It's just gonna require a little bit of copying and pasting. Besides that, it looks like everything is working, which I have to say I'm very surprised by. But it works. So I'm going to have to do this translation. I'm going to have to do, again, finish the refactoring of the scheduler. And I'm going to have to, of course, clean up everything that I just did, finish these operations, but it will be working soon. So that's pretty exciting. However, I'm done for today. And for the rest of this weekend, which for me, weekend when I talk about streaming includes Monday, we're doing Lisp interpreter. I've been waiting for this moment. It's time. Okay, so tomorrow I start with that. Today I'm done. So yeah, all that's left to be done here is clean up, finishing a refactor that I'm doing, implementing this extra functionality, but the entire thing is done. Just needs a little bit of fine-tuning, which I prefer to do off-stream. Tomorrow I'm going to be continuing my Lisp interpreter, and the Lisp interpreter is going to be fundamental. Maybe tomorrow I will be doing a little bit more Emacs stuff or something. I don't know. I guess I'll see. But I will be doing Lisp interpreter stuff Monday as well. And then that Lisp is going to be used to script the operating system. That's number one. And to power my code editor, which I will now structure closer to what Emacs is doing. my text editor, not code editor, which I want to script closer to what Emacs is doing. Maybe even preferences for my applications I want to power with Lisp, and then it should be relatively easy to make a visual interface around them. I did mention how I want preferences in my applications and in my OS to be decent. One thing that I really hate about like being in the system settings for anything in Linux or any settings for any application, and then it's like, wait, how do I do this thing? Google it. Oh, you have to do it through the terminal. It's not in the visual part. So I want to see if I use Lisp as a scripting language for those preferences, can I make it so that I can make it both scriptable with Lisp, but also make an interface around it that is like kind of automatically updated. I don't know. I'm gonna see what I can do with that. Anyway, that is it for today. So yeah, tomorrow we're doing Lisp, and then next week it's time to start implementing some file systems in userspace while this entire thing is fully implemented and stable. All right. Your OS is missing neofetch. How am I supposed to LARP without it? What is neofetch? Can tell I'm not a LARPer because I have no idea. Is a system information tool written in a bash shell scripting language. It displays a logo of the distribution. Oh, is that what that is? I've seen mostly Arch users using this thing, and I never knew. Do I have that? No. I'm assuming you need to install it. It's not a built-in LARPer tool. We're doing scripting with Lisp. So you know what? Maybe the first script that I write is gonna be neofetch. So you can LARP to your heart's content. Okay. Well, everybody, it's been fun. It worked. Very few crashes. I enjoyed doing multi-threading programming. What? Anyway, see you tomorrow.